directly. So this is the command you have to use to perform the post build event. Here just put that command, and in place of the part to DLL, you have to give the part to your actual DLL. So just go to our project. Here we will go to our DLL project. This is the math library. This was our DLL project. Go to x64 debug, and so here you can see this is a DLL. So copy the path of this DLL. Copy as path. Go to a project. Paste it here. Okay. So now what it will do? It will copy our DLL when we will build our project. Let's build a project. Project is built. Once succeeded. Let's see if it has copied or not. Let's go to project and x64 debug. So it has copied mathlibrary.dll after build. That is the post build event. So it has copied it. Now we will check. Now we can do control F5 to check if it is building as well as executing. Means .exe will be executed. So .exe got executed, and here we can see hello world printed. So we have calculated the result. So let's print it. If you're calculating and not printing, then कैसे चलेगा नहीं? Addition of a let's addition of we can do a plus b is equal to, let's give the string std and endl. Okay, so this is cout is defined in the standard namespace. Let's give this. So we can use the addition function here. So let's now control F5, and we can see if we can execute our exe application. So yes, so now here we are able to use our DLL. Like if I will do control plus F5, then my application will be executed, and as you can see, it is printing the result of the addition. So now I am successfully able to use my DLL in my client project. This is how we can build our DLL, and we can attach it dynamically to our client application. This has various advantages. So I already have one video on what are the advantages of DLL, like why do we use it. So now let's come towards the why do we use the C type export in our project. Let's understand why C style interfaces are used in DLL. So C style interfaces are used because of the language compatibility. Basically, what C++ is doing, if we will take the case of C++. So in C++, name mangling is performed. Now, what is name mangling? Let's discuss about that. Name mangling is a case in which if we are having a function like int add, like let's say we had a function of int add. This is our function. Let's open our library. So this is a int addition is a function. So in name mangling, what will happen? This function will be converted to a mangled name. That means something like this will be there. Some string will be there. And this is stored by the compiler in order to perform the function overloading, namespaces, in order to differentiate between the templates, in order to differentiate between the function overloading. So it will create such type of name manglings. C++ compiler will create this. And these name manglings won't be same for different compilers. Means if I am using the GCC compiler, if someone is using the Microsoft Visual Studio C++ compiler, so both compilers will have a different type of name mangling pattern. So name mangling on one thing won't be used in other thing, and this mangled name is present in .lib. That we were having .lib file that was generated along with the .dll. So in that we are having the references to the functions. So these references to the functions are present in the form of name mangling. And this is not common, constant in different terms of the compilers, on different compilers basically. So that is why we want that the name shouldn't be mangled. Means the name should be original in its .lib file. So to keep the original name in the lib file, we will use C-type exports. In case of C-type exports, this name mangling is not performed. So that is one benefit of C-type exports. And hence that was the reason we used the extern C keyword. So let's see this again. Language compatibility, there's name mangling. C++ uses name mangling for function overloading for namespace and templates. Mangled names are compiler specific and that are not understood by other languages. Like if you will take Python and Java or JavaScript, so mangled names are not understood by them. If they are using a particular kind of DLL, then they won't be able to call the function. So extern C disables name mangling, exports functions with the same name, and it makes the DLLs usable by any language that support the C style calling convention. So it ensures that our DLL is a cross compiler and cross language compatibility. So that is why we are using the C type exports. And also why we are avoiding the C++ style exports here. The second thing is that for C++ style, if you want to export any kind of class, then class object layouts are created for a particular object of a class, and these layouts that are created of the objects are different on different compilers. That is why we avoid using the C++ style exports. And vtable differences for virtual functions. Virtual functions are used that are used for dynamic oh, polymorphism, runtime polymorphism. So virtual function tables are created, and those are different for different compilers. And some more reasons are there, like constructor, destructor, and overloaded operators. All these bring complexity when we try to export them from a DLL. So let's understand it with one example. I will give you one example. Let's say if you want, if we have a DLL, like we already had it. Let's say if we want to export a class. So in order to export a class, what we can do is now that let's comment it out. If you will write as a, let's add some multi-line comment. If you will write it as a class um, math library, RARY. Okay. So we are having a class with math library. Then if we will have one function in it as int add int b in this, okay, and we will do return a plus b. Okay. So this is our class. So now in this case, if we will try to export it, how we will export it? We will do that underscore underscore decl spec DLL export, and we will say that we will create what we can do. We can just export a class here. We will do, or we will create one object of this class. Math library. We can math library obj. Okay, so we can just do obj. So this will export the object from the class. But then this will create some issues for the that what we discussed here is regarding the compiler specific objects layout. So if you want to export it, if you want to export a class, then what we can do is instead of that, if we are having this class, we can write int add, we can do int a, int b, and here we can do something like math library obj, and then we can do uh, return return obj dot add of obj dot add a comma b. So in this way we can use classes, and we can then export this DLL export, and we can do int add. So in this way we can export the objects of the classes. This is the second way, and this was also the reason why we shouldn't use this. And in one of my video, I've also discussed about what are the advantages of DLL and why should we use it over static linking. So thank you very much for this video, and you can check out that video on advantages of DLL, and further I will be coming up with explicit and implicit dynamic linking in case of dynamic link libraries. See you all there. Thank you.